In this video, we're going to look at how we can use loops to help us solve problems in assembly language. In the last video, we looked at an instruction which was JEQZ, and it said that if the contents of whatever register came as the first argument were equal to 0, then we were going to jump to the line number given by the second argument. So for example, you might have something like JEQZ R1 12. And if the value of R1 is 0, we would jump to 12, otherwise we would just go on to the next statement. And there are similar conditional jump statements for other types of conditions, greater than, less than, not equal to. They all compare to 0 though, right? So we're just looking at the contents of a single register and seeing how that value compares to 0. There is also an unconditional jump instruction that no matter what will jump to the specified line number. And then there's what's called an indirect jump, jump R, that jumps to whatever line number is stored in the specified register. And we'll talk more about that instruction later in the semester. But here's an example of a program that uses jumps. And the purpose of this program is to read in two integers. One of them gets read into R1, one into R2. And then to print the sequence of integers from R1 to R2. For example, if the user enters 4 and 10, the program would print the integers from 4 to 10. The program actually begins by checking its inputs to make sure that the first input, R1, is less than or equal to the second input, R2. And if it's not, it's going to ask for two new numbers. So let's see how that happens. Let's assume the user gives us 7 for R1 and then 3 for R2. So we then subtract R2 minus R1 and store the result in R3. In this case, R2 minus R1 gives us negative 4. And then we say jump if the contents of R3 are less than 0, jump back to line 0. Now notice what we've done here. We've actually used two lines to get the equivalent of this comparison, R2 less than R1. There's no way to do that in a single jump statement because all of our jumps are based on comparisons with 0. So we have to subtract R2 minus R1 and then compare that result with 0. And in this case, if that result is less than 0, which it is, we're going to jump to line 0 and ask the user for two new numbers. And so when that happens, we end up repeating line 0 through 3, and we'll keep repeating them until the user gives us a first input that is less than or equal to the second. And those lines that get repeated are known as a loop, because the program loops back and repeats statements that it has already executed. Now it turns out that this program also uses a loop to print the numbers. So let's assume that we get inputs of 3 for R1 and 7 for R2. This time, because the result of subtracting R2 minus R1 gives us 4, we're not going to jump because the contents of R3 are not less than 0. So we're going to continue on to line 4. We're going to write the current value of R1. Then we're going to test to see if the contents of R3 are equal to 0. So we do another test, but this time we're testing to see if it's equal. And because it's not, we're going to go ahead and proceed with line 6, which adds 1 to the current value in R1. Then we do another subtraction, R2 minus R1. So because the value of R1 changed, we're updating our value of R3. We want R3 to always be the difference between R2 and R1. So that difference is now 3. And then we do an unconditional jump back to line 4. And so we can see that lines 4 through 8 form a second loop. We write the current value of R1. We then check to see if R3 is 0, but it's not. So we increment R1 by 1 again. It's now 5. We update R3, so it is now the new difference between R2 and R1. We do our unconditional jump. That causes us to write the new value of R1. We check again to see if R3 is 0, but it's not. We increment R1. We update R3. And we keep doing this until finally Once R1 becomes 7, R3 becomes 0. We jump back one more time. We write that final value of R1. And now when we check to see if R3 is 0, it is. And so we break out of the loop and jump to line 9 and end the program. And so you can see we've used our loop to print the sequence of numbers from R1 up to and including R2.